Considered by the Board of Regents one of our peer universities because we service a big city and they service a big industrial city. Susan's a native of Ohio. I actually have known her since I was a teenager. We went to school together at a place called Mount Union College. She went off to Miami University of Ohio. And also, she produced the $15 million worth of cesium iodide crystals from a KZAB experiment when she was working for Harshaw Chemicals. And she then went on to get her PhD in science education, has been doing research on Q methodology and subjectivity within science. And this is the talk we're going to hear about today, and it's related to learning and teaching qualities in physics. So please join me in welcoming her.
All right, so we'll get going. Hopefully. I'm not used to presenting with this laptop. All right, so here we go. So a little bit about me. Nick gave us at least a little glimpse. So I spent 6.5 years after grad school making radiation detectors. There is those are all Bicron ones, and they were our evil sister company, and then we all got merged together. But I've been on the University of Akron faculty. This is my 25th year, primarily teaching physics to engineering technology majors, which is basically like applied engineering. That's kind of the short answer of that. And I teach a software applications class and a programming for technology class that serves those students. My PhD is in physics education research, science ed. I did an incredibly quantitative dissertation, which now I kind of laugh about, but we'll get to that. Anyway, I was unhappy at the time that some of my dissertation members made me do some more qualitative things, which just ends up being kind of ironic. Anyway, as Nick mentioned, I do something called Q methodology. My dissertation had nothing to do with Q methodology. It was a year after I graduated, ran into a colleague at an education research conference, and he said, hey, I took this summer class, and it was about something called Q methodology. You know how you always talk about student evaluation of teaching? It doesn't make any sense to you for various reasons, and not just because it's bad statistics. But he's like, I think that this would solve some of the things that you talk about when you talk about student evaluation of teaching. We should do a study. So we did do a little study. It never got published, but I kind of thought this is a really cool thing. So I used Q for some research studies, or pretty much on my physics classes and on faculty at my university. Then I went to my first Q conference in Athens, Georgia, and found out that William Stevenson had a PhD in physics as well as his PhD in psychology. I found that on a tour bus. We were going someplace, wherever there was to go in Athens, Georgia. I couldn't even tell you now. But I sat next to a guy named Byung Lee, and he asked me what I did. He's a journalism professor at Elon University, and there's lots of political science people in this Q methodology group. And I said, well, I'm a physicist. He got really excited, not like people usually get excited when you say you're a physicist, and they go, wow, that's really nice. And you're like, well, moving along with some other topic that isn't scary. So he got all excited, and he told me that William Stevenson, the creator of Q methodology, was both a physicist and a psychologist, and that part of how he ended up with his dual PhD is that he wanted to study something called psychophysics, which was kind of a stimulus response idea that built on ideas of physics as well as psychology. And I thought, well, that's really interesting. And then people started telling me more and more about how William Stevenson used concepts from quantum mechanics to create Q methodology, and how he often wrote about this. And for the most part, people in the International Q Methodology group have no idea what most of these things mean. They just read popular science kind of versions on quantum mechanics, trying to understand the big picture because they're all social and behavioral research types of people. So next thing I knew, I was becoming more of a methodologist than I was a physics education researcher, because life is a funny thing, and that's just kind of how things happen. And now I have a real focus on philosophy of science, and it's just kind of funny how all these things kind of merge together. So from all of those beginnings, I ended up being, well, in the long run, the president of I4S, which is the International Q Methodology Association, hosted a conference in beautiful Akron, Ohio, was on the journal editorial board. Then this in turn led me to become more involved in mixed methods through my now lated advisor for my PhD in education. And next thing I knew, I was writing book chapters in handbooks of mixed methods, research, and the like. So I have one published actually with Isidore Newman, my advisor, and then 3 more that are all in various processes of being published. And, 50 publications, lots of presentations, journal reviewer, and all that kind of stuff. So I thought I'd start off with a quote because for whatever reason, physicists seem to like quotes, and I like quotes. So I have to have a quote. My students are used to this kind of thing. I have quotes and cartoons and things. So anyway, William Stevenson said, everything is inherently subjective. And so I would never have predicted this is where I would have landed way back when I was an undergraduate or even graduate student in physics, but here I am embracing the world of subjectivity, right, with this kind of quantum mechanical focus. So it seemed appropriate after I looked at the list of presenters that you have had in the recent past that I should prepare you and say, and now for something completely different. So this is the presentation abstract. I won't read it to you, just like I won't read to my students, but you guys have sheets so you can read it at your leisure. So this is a picture of William Stevenson. First time I saw his picture, I thought, he looks like a physics guy. PhD in physics in, I think it was like 1935. He was focused on vacuum tubes and some other things of the day, and then went and got his PhD in psychology, studied with a guy named Spearman, who was the creator of factor analysis, used in social science and behavioral research. It ends up that factor analysis is exactly the same mathematically as quantum mechanics. I was very excited in my advanced statistics course in the education PhD program when Isidore started talking about factor analysis, and I was like, got really excited, scared a bunch of education PhD students in the class because I started talking about quantum mechanics and wasn't this the coolest thing ever? And they didn't seem to think so. I don't know why, it's the coolest thing ever. But anyway, Stevenson had a very strange kind of series of employment opportunities. He started off in, I believe it was the University of Oxford, worked with Spearman and a guy named Cyril Burt, ended up leaving England and going to the University of Chicago, where he was a psychology faculty member and didn't get tenure, left, ended up working in marketing in New York City, and then ended up, that's right, teaching journalism research at the University of Missouri. Life's a funny thing.
Neither did Gell-Mann get tenure.
What's that?
Neither did Gell-Mann get tenure at the University of Chicago.
Really?
And he invented the quarks.
Well, they apparently had some pretty stiff competition or something there. All right, so what is Q methodology? I keep talking about it, but we need to kind of talk a little bit more about it. So it is a scientific way to determine divergent perspectives within a group about a topic. See, I already sound more like a social scientist. It's a mixed method, which means that it mixes both qualitative and quantitative. In psychology, especially during Stevenson's time, psychology was very, very quantitative. They really shunned qualitative. In fact, I think it was Skinner, like the Skinner box, actually described psychology of that time as more focused and quantitative than even physical scientists were. But psychology in a lot of ways was trying to make themselves more of a science, and they thought they could do that by becoming more quantitative and throwing out subjectivity. I always say it's because they really don't understand how scientists work, or how we come up with ideas, and how in a lot of ways science always has qualitative aspects, right? But when students take physics in high school or college, right, what they remember is they had to pick an equation, turn a crank, and get an answer. And so that's kind of my theory of how they think it's just nothing but quantitative. It's 80 years old. Stevenson wrote a letter to Nature in 1935. It was one page, outlining his ideas for what he called originally Q technique. And then it spent his lifetime basically fine-tuning it. It's used in a variety of fields: education, political science, environmental studies, journalism, marketing. And so what does it mean that it allows us to determine divergent perspectives? Well, I'm going to talk about that here in a minute. Basically, you start off with concourse, which just means that you collect lots and lots of different kinds of communications, usually written communications, although Stevenson used other kinds of items, including sense and pictures. You can collect statements from interviews, open-ended surveys, newspaper articles, and then you take a subset of these items and people actually sort them into a grid. So why not use Likert-SCALE surveys, right? We've all done surveys. Likert-SCALE, some people call it Likert, but it's really Likert. That's the kind of survey that you take where you have maybe 1 to 5 and you select, 1 strongly disagree to 5 strongly agree. And there's a reason why Stevenson really rejected the idea of surveys for this kind of research. Mostly because averaging in surveys, like student evaluation of teaching, right, just averages things. And so you obscure all the individual differences and you lose a lot of meaning, right? So if you think about it in a classroom, right, everybody in your classroom has the same experience, yet they don't all get the same grade, right? And they don't all have the same experience inside, right? Their subjective viewpoint of your class might be very different. Somebody thinks you're the funniest person in the world, and somebody writes on, ratemyprofessor.com, I think she has short woman syndrome. Yes. Somebody wrote that about me. Hey, somebody also wrote, if you just do what she says, you're pretty much guaranteed to be. So it kind of evens out. So if you think about it, right, here's a grade distribution. I just stole it from somewhere. I just Googled it. Right, so here's a typical grade distribution for a class, right? And for maybe a test or something, right? And of course, it's bimodal, meaning that there are, right, 2, or to quote one of my graduate faculty instructors from grad school, there is an upper circle and a lower circle, right? But they were all sat through the same class, they did the same homework, so how did this happen, right? Because not everybody has the same experience, even though we kind of think in our heads that they are experiencing the same situation. And this is how Joe's comment to me about student evaluation of teaching kind of led me into doing this Q stuff. So here is what a study might look like from a participant's view. We have a sheet of paper. There's some instructions and some demographic questions on the front. And now they're given an envelope full of statements. This one happens to be a study. It's a continuation of a study I did on speech on campus, free speech on campus. So they go through this stack of items, and this one happens to have 55 little sheets of paper, and they put them in one of 3 categories. Like my view about, in this case, speech on my campus, unlike my view of speech on my campus, and a kind of neutral pile. Usually they're kind of equal. In this particular case, there was a little more maybe on the left there for the disagree, like unlike my view, than the like my view, and then the neutral is kind of in between. And then you literally shuffle these around on this grid until you're happy with what it looks like, and then you write the numbers inside the grid. I think that actually is the next picture. Somehow I got them out of order. So that's the sorting part of this, and Stevenson called this the Q technique part. So the idea is that everyone who reads these statements, right, will see them based on their own point of view. So their sort, each individual sort will give a snapshot of their viewpoint. And it's called self-reference. But it basically lets an individual express their feelings. I've done this a lot with my students. On at least one occasion, I had a woman from the Middle East in my class. I think it was evaluating my flipped physics class, and she came up to me and she was like, "I don't understand what you want. Like, how am I supposed to order these items?" And I said, "Well, based on your viewpoint, like, I want to know what you think about this." She was like, "You want to know what I think about something?" And I said, "Yes." She was like, "I don't think anybody has ever asked me what I think about something." So it's a little different for a lot of my students. Then after the sorts, a lot of times people use post-sort interviews, because I'm typically doing this in a classroom. I usually have them write comments. It's always interesting to see the kinds of comments my students write, right? So one of the things I'll ask is, so you put, 4 items under the +5 most like my view. Why did you select those to go there? And some of my students write, because I thought that's where they belonged. And then other students will write a whole lot, right? So for instance, a number of years ago, I did a study about epistemology, how students think about teaching and learning and knowledge. And I had a student named David who was very generally quiet. He was not a good student. Not during the first semester of physics. He was not a good student. But he had an epiphany while he did this Q sort, which is part of the quantum mechanical aspect of sometimes the process of this measurement changes the viewpoint, right? So measurement can have an impact. And it had an impact on this kid, right? So he wrote a lot. He wrote how he realized during this sorting process that he had been thinking about college all wrong. And he was not doing what he should have been doing. He wasn't thinking about how much he was getting out of classes, and it just went on and on. I cried in my office. And then the next semester, because I usually have students do this as extra credit on their final exam. They always want to do it because it's extra credit on the final exam. Anyway, the next semester, David was in the second semester of physics with me. Totally different kid. Did all his homework, asked questions, came to my office hours. So sometimes, but not always, the sorting process helps my students have an epiphany. Anyway, we call the set of participants the P set. I don't really know why. We do factor analysis, which again is kind of quantum mechanical in its mathematics. Theoretical sorts come up for the different viewpoints. So instead of averaging everybody together like you would in a survey, right, we actually group them based on factor analysis. So sorts that are similar, so similar viewpoints, actually get grouped mathematically. And then these factor arrays are created for each viewpoint. It all makes sense when I show you some examples. And then we can actually not only differentiate the viewpoints, but we can describe them in great detail, which is part of the part of the mixed methods aspects of this research. And it also tells us how mathematically, how the positions of the statements, right, are distinguishing for different viewpoints. And then finally, it provides consensus, which is also often helpful. I actually used that for the very first Q study I did. I used the consensus more so than the differentiation of views to get a group of faculty to focus in on what we had in common, because there was a lot of arguing. And then we used the consensus to actually move forward in a plan to create a school of technology, which then never happened because that provost left, right? And then because that's what administrators do. And then we interpret these views, and right, a lot of times there's a lot of who cares and so what, right, gets answered through that part. So a little bit more about Q and quantum mechanical parallels. The form of factor theory in Q methodology fits squarely with the mathematical formulation of quantum theory in physics, right? We already talked about that. There is the similarity between treatment of causality and probability. We talked somewhat about the uncertainty principle in Q methodology. You can see why some of the political science people just skip over a lot of the theoretical aspects of Q because they're like, I don't know what that means. And then, right, we have quantum states in quantum mechanics, and Stevenson called them states of mind or states of feeling. Are these quantum states are the factors that emerge, right? And then he also quoted Heisenberg, it's a matter of preparing the phenomena of nature so that they can display their structure. Of course, Heisenberg did not say that about quantum mechanics. He said that about, or he did not say that about Q methodology, he said that about quantum mechanics. And then Stevenson, in turn, said, as it is for Q factor theory in psychology in its search for natural subjective phenomena, it is a matter of preparing phenomena of mind so that it can display its structure. So that's the factor analytical part, is displaying the structure. So what's in this talk besides talk of quantum mechanics and outlining Q methodology? I'm going to talk about two of my previous studies. One of them was about evaluating a flipped physics classroom. All my classes are flipped, and I'll talk a little bit about what that means. And then a more recent study where I evaluated students' views about offering a physics course online, my physics courses, the ones that they took, and what they thought of that. So I thought both of those topics